Hi, Gritov. Welcome to Euclidean geometry, solving proportionality theorem questions. I know it's been quite long ever since we posted a session, but we are just working on some very interesting session on learnable math, and you'll see them as they approach. For today, let's go and just focus on some of proportionality theorem questions from the Department of Basic Education and see how we can actually try to solve those. Okay, so this is the first question, and it's obviously wanting you to apply proportionality theorem. I'll just show you strategies that you can use that will help you to solve almost all proportionality theorem questions. Okay, so the first one says in the diagram below, P is the midpoint of AC. That's a very important statement. Let's not forget about it, right? So P is the midpoint of what? Of AC. So what we're gonna do in this question really is write down whatever property that you have according to the statement. Okay, so what does it mean when P is the midpoint of line AC? It means that AP will be equals to what? Will be equals to PC, because P is the midpoint. It's on the midpoint of the line AC, so it means that our PC will be equals to what? Will be equals to our AP there. So I'm just gonna represent that in my diagram. Let me just add that properly. So AP is equals to PC, don't forget, because P is the midpoint. Okay, so let's move in ABC, and R is a point on AB. We can see that R there is a point on line what? On line AB. Okay, such that RS is parallel to what? To BP, and they've just indicated with the sign of parallel there to say RS is parallel to BP. Okay, so they're saying AR over AB is equals to 3 over 5. So the ratio of a line AR and AB is 3 over 5. How do we represent ratio now? So if they give you ratio AR over AB is 3 over 5, that does not mean that your AR is 3 and your AB is what? Your AB is 5. It does not actually mean that. So it's the ratio. So in a ratio, it means that there's a certain variable that's multiplying with that value. So AR, we're just gonna represent it as what? It's gonna be because they say 3, it's corresponding with 3, so it's a ratio. So we just write AR as what? As 3x, to show that there's a certain variable x that's multiplying with that 3 to give us the total length of what? Of AR. So with AB is 5, it's corresponding with 5. So also, because this is a ratio, it's just gonna be what? 5x, to show the total length of AB. There's a certain value of x that's multiplying that one to give us the total length of AB. So that's how you represent that. Remember, this is AB, right? From the here we can actually find something. Can you see? We have 3 here, we have the total as 5. We can actually calculate what? Our BR. Can you see? Because the total is 5 from 3. So it will be 5 minus 3. BR will be what? Will be equals to 2x. So that's it. We just wrote it there. So let's see. We can now go and calculate now. After you fill up your whole triangle, you can just go and calculate. Okay, so they say calculate given reasons the following ratios. So A, it's AS over what? Over SC. AS over SC. Let me show you with an yellow color. AS is this line. This is AS over what? Over SC. Over SC. And our AC is this one. Is it? This is our SC. Okay, so how do we calculate? Very, very important. In a triangle where you can see that there are lines parallel to one side of a triangle, you must be thinking of proportionality theorem. But very, very important, you don't just go and write your proportionality theorem. You don't just go and select sides. You select the sides that are going to be very, very useful in you solving what? In you solving this equation. Okay, so let's go. Now we want to get the ratio of AS over SC, right? So you just have to identify on which triangle that you can apply proportionality is your AS and your SC. Okay, let's start with AS. Can you see that your AS is here, right? And your SC is here. So if you check AS, it's on this triangle here. Take a look at this triangle. Remember, you must identify a triangle where there's a line parallel to one side of a triangle so that you can be able to use proportionality what? Proportionality theorem. Okay, so there is it. So on that triangle, you can see that there's a line that is drawn parallel to one side of the triangle. Then we can apply proportionality what? Proportionality theorem. So look at this. On this triangle, really, we can actually come and calculate AS over SP. Can you see? On that triangle, we can get AS over SP because there's a line parallel to one side of a triangle and we have the length of those sides is 3x and what? And 2x. So it means that we can get our AS over what? Over SP. So before actually going and calculate the ratio of that. Okay, so let's just start with that. We're going to calculate AS over SP. So I'm going to say AS over what? Over SP. It will be equals to what? It will be equals to AR over what? Over RB. Why are we saying AS over SP is equals to AR over RB? It is because there's a line drawn parallel to one side of a triangle. In other words, it's proportional to what? It can say proportionality theorem. So someone can write it like this: proportionality theorem. Don't forget to show which lines are parallel. It's because RS was parallel to what? To BP. So that's our reason. Okay, so we can go and calculate AS over SP. AS over SP is going to be equals to, what is your AR? Your AR is 3x, right? It's not 3, it's 3x. That is the length of AR. And what is your RB? Your RB is 2x. So x and x will cancel out each other. You have AS over SP is equals to 3 over 2. You can now go back to your diagram and replace the 2. Okay, so AS is 3, but that's a ratio, right? So you're just gonna write it multiplying with another variable to actually show the length. So I'm going back to AS. I'm gonna write 3. So because this side you use the variable x, when you move to the other side you must change the variable, right? So that there might not be that ambiguity because it's a different side and it's actually a different length. So AS is equals to 3. So I mean according to the ratio. So I'm just gonna choose a different variable to represent the side of AS. So I'm gonna write 3y. Okay, so SP is corresponding with 2 where there is SP. Also this side we're just going to use the same variable on the same side as we did this side. We use the variable x, so this side we just choose any variable. You can choose any letter, M, P or so. Yeah, so this SP is what? Is 2, so it's gonna be, the length is going to be 2y. Okay, so after calculating that, we can now go and get get the ratio. Now look at this. The ratio wants us to get the ratio of AS over SC. Can you see? Can you see that so far we only know AS, which is what? Which is 3y, right? We don't know SC, but we can calculate SC. Can you see now? We can get SC. Why? Because we can see that SC is actually equals to SP plus what? Plus PC, right? So SC is equals to SP plus PC, right? Don't forget, we already calculate SP from our proportionality there. SP was 2y, but we want to calculate PC now. PC, don't forget, we said P, we were given in the statement P is the midpoint of AC. It means that P cut AC in half, right? So it means that PC is equals to what? Is equals to AP. So where there is PC, I can go and substitute by what? By AP, because they're equal. I can write them a reason to say PC is equals to AP by midpoint theorem. So, or midpoint, because P is the midpoint of AC, right? So I'm just replacing my PC by what? By AP, because I know P is the midpoint. It cuts the line into half. It means that side and that side are equal. What is our AP? Our AP is equals to 3y plus 2y. Okay, so that one will be equals to, or maybe let me just write it here. I'm replacing my AP, or rather I can say this is the same as AP. So I will replace my AP by 3y plus 2y. Then I can finally get my SC. SC is going to be equals to what? It's going to be equals to 2y plus 3y plus 2y is 5y. This is going to give us 7y. Okay, so that was quite simple. You just had to know to use your proportionality theorem and also use this idea that P is the midpoint. Then we can go and get the ratio AS over SC. What is our AS? Our AS is 3y. What is our SC? We just calculated it is 7y. Then y and y will cancel and our ratio will be 3 over 7. So that's our ratio. Okay. Okay, let's now go to B. For B, they want us to calculate RT over TC. Okay, RT over TC, let's go and identify that. Let me use a different color. RT, yes, RT, can you see? Over what? Over TC. What do I do if I'm required to calculate the ratio in where there is triangles that are having parallel lines? You must think of proportionality theorem. Okay, what is very important? Identify the triangle in which your length are found on, where you can apply proportionality theorem. So can you see that RT over TC, it's found on this smaller triangle where we can apply proportionality theorem. Why are we saying we can apply proportionality theorem? Because on this smaller triangle here, we have RS, which is parallel to what? Which is parallel to BP. So most of the time they'll just put this parallel line this side, and someone might say, no, this line is not parallel to that. But look at it. BP is still parallel to RS, although this symbol for parallel line is placed outside that triangle, right? But it's still the same line. Someone can put it there to say this one, just to show it clear, this one is parallel to this. Then we can apply proportionality theorem and go and get our RT over TC. Okay, so let's go and do that. So RT over TC, because it's found on this triangle where we can apply proportionality theorem, then it will be equals to what? It will be equals to SP over what? Over PC. Why are we saying they're equal? Because of proportionality theorem, and we can also indicate the lines that are parallel, because RS is parallel to what? Is parallel to, someone can choose to say TP, right? So because RS is parallel to TP, or rather you can just write the whole length. It's still the same to say RS is parallel to BP. Okay, but just to be more relevant, we can just show them here to say it's parallel to TP. Okay, so that's it. We can go and get the ratio RT over TC. It will be equals to, what is your SP? We already calculate SP. It was 2y over, what is your PC? Remember PC was equals to AP, because of P is the midpoint of AC. So it's equals to 3y plus 2y, which we saw it was 5y. So that was our PC there. We are substituting PC, which is 5y. Then y and y will cancel. Then the ratio will be 2 over 5. Okay. Okay, so because our ratio of RT over TC is equals to 2 over 5, I'm just gonna write it again in my diagram. So always do this when you are solving proportionality theorem questions. Once you get a ratio, go back to the diagram, put those values so that they can actually help you to answer the questions that will be following. So RT is 2 over 5 because RT is another side. Can you see? It's a different side. It's not like this side. It's not like this side. So this side we chose to use variable X. So this side we chose to use variable Y. You can choose any variable. So this side we're gonna use a different variable. RT is corresponding with 2. So where there is RT, I'm just gonna put 2, maybe 2Z, right? 2Z or 2M, any variable you like. But on the same side, you must use the same variables. TC corresponding with 5, for where there is TC, I'm gonna put 5Z. Okay, so just to help us to answer the question that will be following. So let's go to C. So for C, it says, let me use a white color rather. C, it says determine the ratio of area of triangle TPC. Let me highlight for you TPC. Let's go and check TPC. Okay, so TPC is that smaller triangle there. I hope you can see it in red. That is TPC over area of triangle RSC. RSC. So RSC, I'm just going to highlight it with red on its outside. RSC, there is it. Is that triangle. Can you see? This is RSC. So they want you to get the ratio of these triangles. So this question really, how do you solve it? You can use area rule, right? But then you'll see something. Okay, let me just write area rule of this one. How do we get the area of triangle TPC? And you must now understand that we use area rule because this is not a right angle triangle. So if we want to calculate the area of a triangle which is not a right angle triangle, we must think of area rule. Okay, so just gonna use area rule. How is it gonna work? Say area of triangle TPC, which is the smaller triangle, so it's gonna be equals to 1 over 2 times. You're gonna choose the side that are known, right? That you already know. We have PC there, so it's gonna be PC times we have TC there times TC. Then you say multiply by the sign of angle that is included there. So you say this side, and the sign of angle that is included, or that is formed by those two lines. So it's the sign C. Okay, so it will be divided by. Okay, so when you go to this other triangle under here, right, remember you want to get the ratio. You don't know angle C, so you must write the area of this triangle again in such a way that you'll be having similar angles so that the sin C and sin C may cancel out each other. So it means that also in area of triangle RSC, we're just gonna choose this side, which is RC, this side, which is RC, and this side, which is what? Which is SC, so that our included angle may also be what? May also be C, so that sin C and sin C will cancel and we are left with the ratio. So it will be 1 over 2, which side? RC multiplied by what? By SC multiplied by what? By the sign of the included angle there is still sin C, so that we want this and this to cancel because we don't know the angles, right? We want to be left with the ratios. 1 over 2 and 1 over 2 will also cancel. We are left with PC. What is our PC? Our PC is 5y. What is our TC? Our TC is 5z. Okay, so what is our RC? Our RC, look at RC now. Okay, look at RC. RC is this one, from this point to this point is RC. It's 2z plus 5z. So RC is 2z plus 5z. Multiplied by SC. What is our SC? Our SC is this one. It's 2y plus 5y. So it's 2y plus 5y. We can go and simplify that. That will give us 5 times 5 is 25yz divided by 2 plus 5 is going to be 7z, and 2 plus 5 is going to be 7 because that is 7y. Okay, So 7 times 7 is 49, so it will be 25yz over what? Over 49zy. Okay, so the z and z will cancel, y and y will cancel. We'll be left with 25 divided by 49, which is 25 over 49, and that will be the ratio of this area of triangle TPC over area of triangle RSC. So we just use the area rule, but be careful when you use this area rule. You must make sure that you are what? You are the side that you're gonna choose, because with area rule, if you have a triangle like this, if you choose this side and this side, really, and you're just gonna see sign of C. So also on the denominator there, make sure that you are choosing the length in such a way that they will include the same angle, so that the sin C and sin C will cancel and you'll be left with the ratio like that. Okay. Okay, let's now look at this different question and let's see how this goes. Okay, so it's a different question. Also, really, I want us to focus more on question 4 and some of them, and obviously to help you to conceptualize how you can actually solve these proportionality theorem questions. Okay, so it says in triangle ACE, can you see ACE is the bigger triangle there? Is that bigger triangle? Okay, so we have BG, which is parallel to what? Which is parallel to CF, and they've indicated with those symbols there that this line is parallel to this one. Okay, we also have AF is equals to FE. Let's go and represent that. Very, very important statement there, to say AF is equals to what? Is equals to FE. Okay, so we have AB, which is 2 centimeter. So where there is AB, I'm gonna put 2 centimeter, and we have BC, which is 3 centimeter. So where there is BC, I put 3 centimeter. Okay, we have CD, which is 1 centimeter. Okay, and we also have DE, which is 4 centimeter. Okay, so they want us to get the ratio of EG over what? Over GA. So number 1 wants us to calculate the ratio of EG over GA. How do we do that? So in a triangle where there are lines that are parallel to sides of a triangle, you must think of what? Of proportionality theorem. Okay, so the thing is, this is quite not really straightforward, where you're just gonna get the sides that are just in those triangles. You get some of the sides are actually in another triangles where you cannot apply proportionality theorem. You just have to relate this until you finally get the answer. Okay, so let's go and check where is our EG. Okay, because we want to get the ratio of EG and GA. So let's go and check EG. Can you see EG is this one here? Okay, this is EG. Okay, fantastic. And we have over GA. Okay, GA is on the same side as that one. Okay, can you see? So this is quite or less related to the question that we did previously. It's just that they just give you in a different kind of different way, because instead of telling you that F is the midpoint of AE, they just instead told you that FE is equals to what? Is equals to AF. There, AF is equals to FE instead. Okay, so what do we do in this case? Can you see that in this case we can't really go and get EG over GA same time, because if you check EG over GA, you can't say they're found on that triangle. Okay, can you see AG? It's this triangle which has a parallel line there, but there's no other side. Like for GE, this line is not parallel to that, therefore we can't say we're just gonna get it straightforward. So in that case, you have to calculate some of the sides separately, then you go and do your arithmetic, then get the answer there. Okay, so the first step here will really be what? Will really to calculate GA, because it's quite easier to calculate GA than EG same time. Okay, so to get GA, we're just going to use this triangle here. Can you see? Because there's a line drawn parallel to one side of a triangle, so we can get GA over what? Over GF, right? Because we have this side, we have this side, so we can get that one. Okay, so our first step will be to calculate GA. So we're gonna write to say AG or GA over what? It will be over GF is equals to what? Is equals to AB over BC. Why are we saying this one over this one over this one is equals to that one over that one? Because there's a line drawn parallel to one side of a triangle. In other words, there is we can apply what we say, proportionality theorem, and also don't forget to tell them the side that are parallel, because BG is parallel to what? To CF. So that's why we are saying AG over GF is equals to AB over BC. Okay, so we're just gonna substitute there. Let me go and substitute AG over GF. What is our AB? Our AB was given as 2 centimeter, BC was given as 3 centimeter. This will cancel this, we'll be left with 2 over 3, and that will be the ratio of what? Of AG over GF. So I'm going back to my triangle and replace that. I'm just gonna replace my AG by 2. So this does not mean that AG is 2 centimeter, right? Here, but it's a ratio, so it means that we must write it relating it with another variable. We can choose x here. So where there is AG, I'm just gonna put 2x to show the length of AG, and where there is GF, I'm gonna put what? Gonna put 3x to show the length of GF, because that's how we move from ratios to representing the length, to show that there's actually another variable multiplying that ratio to give us actually the length. Okay, so we are not yet done. We just calculated GA now, which we saw it is 2x, right? So it is 2x there. So what's left now is to go and get our EG, so that we can finally get this ratio. EG, how can we get EG? Can you see that EG is this length here? Or maybe let me use red to just show EG. Here's EG. EG is made up of GF and what? And FE, right? And FE. Don't forget that, but our FE is equal to what? Is equal to AF from the statement there. FE is equals to FAF. So where there is FE, we can replace it by AF. And you can see from your diagram, AF is made up of 2x plus 3x. We just calculated that. So where there is, so I'm saying but FE is equals to AF. So we were just given that. So we can replace FE by FE by AF, and we can just replace our AF by 2x plus 3x, which is 5x. So what is our GF? Our GF is 3x there. We calculated this as 3x plus, what is our AF? Our AF is what? Our AF is 2x plus 3x. So that will give you 5x plus 3x. Our final answer will be 8x there for EG, because it's 3x plus 5x, which is 8x. We can now go and get the ratio. Very simple. Our EG, which is 8x, our GA, and we just calculated it. We showed it there. It is what is it? It is 2x. So x and x will cancel. 8 divided by 2. So this will be 4 over what? 4 over 2. Okay, can you see? So it will finally give us, to finally give us 4 as the ratio. Or we can write it as 4 over 1, which is 4. Okay, so that's actually the ratio of EG over GA. Okay, let's move to number 2 now. It says prove that DG is parallel to CA. Okay, let me go and highlight that. DG, where is DG? Here is it, this green line, DG. is parallel to what? To CA. CA. Prove that this line is parallel to this one. Can you see that those two lines are really corresponding properly with the triangle AEC? Can you see on that bigger triangle? So how can you prove that this line is parallel to this? Okay, we can use the converse proportionality theorem. That says that if there are two sides that are on the same proportion, then the line that divides them will be parallel to the third side. Okay, so you can see that we can actually use that theorem now, because we want to prove that that line is parallel to that line, and we can see it correspond properly to that triangle. So if we can manage to prove that this side is proportional to this side, right, then we can conclude that then there is a line that divides those that is parallel to the other side. So that will be the converse proportionality theorem. So that's basically what we can do there. Okay, so we're just gonna show that they are in the same proportion and conclude if it is possible. So I'm just gonna get the proportion of this side here and the proportion of the other side. So to get the proportion, I'll say AG. Oh, let me use a white color. AG over what? Over GE, and we already calculated this. But it is AG, it's 2x there. Let me just use what I have there. 2x there over GE is 3 plus 5, which is gonna be 8x. So this will be x, and x 2 over 8, it's gonna be 1 over 4. So that's the ratio of what? Of AG over what? Over GE there. Okay, so we're gonna get the ratio of this one over this one again, and you can see it's also 1 over 4. So, but let's go and show them. CD over DE is equals to 1 centimeter over 4 centimeter, which is 1 over 4. Okay, so that will be 1 over 4. Can you see that the ratio of that side, AG over GE, is equals to CD over what? Over DE. Can you see that they're equal? Why are they equal? Because both of them are equals to 1 over 4. Right. So the ratio of that side is equals to the ratio of that side. It means that side AE and side CE are in the same what? Are in the same proportion. So if two sides are in the same proportion, then it means by converse proportionality theorem, then there's a line here that is parallel to the other side of a triangle. So we can now conclude that therefore it is true that DG is parallel. Okay, let me write it properly. DG is parallel to what? To CA by what? By converse proportionality theorem. Okay, so you can give that reason to say by converse proportionality theorem, or rather someone can say sides in proportion. Sides in proportion. So we know that if we have side in proportion, for example, if we have this side that is in proportion to this side, then we can conclude this line is parallel to that. Okay, similarly with proportion, if this line is parallel to that one, then these two sides must be in the same what? In the same proportion. So that's just the converse midpoint theorem that they wanted you to use there. Okay, let's quickly go to number 3. Okay, number 3, they want you to get the ratio of what? Of EK is to KB. Okay, so this is the same as EK over what? Over KB. They want you to get this ratio. Let's go and check that length to say on which triangle is it found on, where we can apply proportionality theorem. It's a little bit of a mess here. Let me just delete those lines and all that, so that you may not get confused. Yeah, I think that's better. EK, here's EK here. BK is that one. Can you see? Or KB is that one. Can you see that they are found on that smaller triangle where we can apply proportionality theorem? So the idea here is to say, if they want you to get the ratio, get the length, check on which triangle is this length, where I can actually apply proportionality theorem. Okay, so that's the idea, so that you can actually get the ratio. So you can see that line, it's found on that smaller triangle where we can apply proportionality theorem, because there's a line here that is parallel to this line here, so they are parallel. So it's as if you can put that parallel line there, because it's still the same line, they are parallel. Can you see? We can apply proportionality theorem and it can be very easy to get that ratio. So let's just go and get the ratio. It's EK over KB. It will be equals to what? It will be equals to GF. We said EK, right? So EK is corresponding with EF, this side, EF over what? Over FG. So what we are doing really is to say this one over this one will be equals to this one over that one, because there's a line parallel to one side of the triangle. In other words, we are applying what? Proportionality theorem. Don't forget to show them the lines that are parallel, is because our BG is parallel to what? Is parallel to CF, or we can just indicate that one to see is parallel to KF there, because we can see they're parallel. Okay, so we can go and solve. Very simple. EK over KB, it will be equals to EF. What is our EF? It's 5x. So that's why it's very important, after calculating the previous questions, just make sure that you write whatever value those length are equal to, so that it can be easy for you to calculate the next question. So after calculating the previous one, go and fill up your diagram so that it can be easy for you, so to identify that. What is FG? FG is 3x there, so x and x will cancel. This will give us 5 over 3, so it will be 5 over 3 there. Okay, so after getting that it's 5 over 3, I just go back in the diagram and fill it, right? So we're gonna just fill our diagram. Don't forget, we've just proven in number 2 that DG, this one DG, DG, let me just put it here, maybe, is parallel to what? Is parallel to CA. So yeah, now we get the ratio of this one. It's 5 over 3. Let me just write it here. It's 5 over 3. Then it will be 5 is to what? 5 is to 3 there. Okay, so let me go and write it. Where there is EK, yes, where there is EK, we're gonna substitute with 5 is the ratio, right? So we must choose another variable, so it will be 5 what? 5 maybe y, because we already use x that side. So this side we're just gonna choose a different variable. So BK or KB, which is 3, its ratio, so it will be 3y there. Okay, so now we can move to the next question. Okay, number 4. So this is quite a challenging question, and okay, let's just get to it. You see, there's a determine the area of triangle AFC. Let me highlight AFC in yellow. There is it. That is our AFC. And which one? Area of triangle CEF. So CEF, I'll just highlight it in blue. There is it. Okay, so they want us to get the area of the area of the ratios of the two areas, right? So of that triangle and that triangle. So obviously I told you that you must be thinking of what? Of the area rule, right? But with the area rule, if you have two sides, obviously you have to include the included angle there according to the area rule, and we covered that in I think it was session 7 in our trigonometry. I'll also put that link of those rules down here, so that you can go and watch the session on how to calculate the area of a triangle. But otherwise, I think you can also understand it within this lesson to say, how are we gonna get the area of triangle? Let me use a white color. Area triangle AFC, right? this is over area triangle CEF. Okay, so with area of triangle AFC, so check the sides that you know them, right? So we say 1/2 according to the area rule, 1/2 times. Look at this. Which side do you know in AFC? In AFC, we have this side here, which we know, and the other one which we know is this side here, right? So we have that side and that side. So we just use those two sides. So it will be AC multiplied by what? The other side there that we know is what? Is AF, right? Multiplied by what? The sine of the angle that is included there is A. So it will be the sine of A there, which is the angle that is included between the two sides. So that's actually the area rule. So it will be divided by 1/2 multiplied by. Remember, we must ensure that also here we have a sine of A, right? We must have sine of A. So the sine of A and sine of A will cancel out each other, right? So in a sense, if you don't get sine of A, then it will be a crisis. You won't be able to get that ratio. But let's go and see. With triangle CEF is the blue one there. Is this blue one there? That our CEF. So let's check the side that we know. We have CE. We know this side here. Can you see? We know that side. So it will be 1/2 times CE multiplied by the other side that we know is FE. Can you see FE there? FE here on this triangle. FE, we know it is 5x. So we have FE multiplied by. Take a look at this. This is not the sine of A, but we're just gonna write it because it's the angle that is included between the two sides. Remember, in sine rule, we must use the angle that is included between the two sides there. Can you see? And it's E, so it will be sine of E. Someone might be saying, but say, you said it must be sine of A. Are we gonna simplify that? Yes, it's possible. We're just gonna simplify. You'll see it. Now you have sine of E, on top you have sine of A, right? Remember, you just apply the sine rule. You are getting these two angles are different. What do you do in this case? Go and check whether there's no relation between these two angles. Is there no relation between the two angles? That's the thing you start asking yourself. Is there no relation between angle A and E? So that if maybe angle A and is equals to angle E, then they can cancel out each other. Yes, there's a relation, but you must be very observant to identify this relation. Take a look at this side, CA. It's equals to what? It's equals to 5 centimeter. CA is 5 centimeter here, right? And take a look at this side again. 1 plus 4. It's also equals to what? 5 centimeter. Can you see that AC is equals to CE? Can you see the two sides are equal? Then we can say if the two sides are equal, is an isosceles triangle, then the base angles will be equal. So in a sense, angle A is equals to what? Is equals to angle E. Why? Because base angle of isosceles triangle are equal. It's because we just saw that AC is equals to CE, which is equals to 5 centimeter. In a sense, the reason here will be what? Angles opposite equal sides. So angles opposite equal sides. So that's our reason. Or someone can write base angle of isosceles triangle are equal. Then we can actually go and replace our E there with what? With A, because they're equal. So I'm just gonna do it there on that step to say I'm replacing my E with A, because we just proven that the two angles are equal. So then sine A and sine A will cancel. So you can see in this example, it's not like the previous one where it was clearly obvious where you take the side that are equal, you are just getting the same angle. But in this case, you were getting different angles. So you had to look at the relationship between the two angles so that you can finally deduce that, oh, this angle is equal to this by what? By isosceles triangle. We have an isosceles triangle, then base angles are equal. So hence, the two angles were equal. We can cancel out those two and this one, then we can go and finally get the ratio. What is our AC? Our AC is 5 centimeter. What is our AF? Our AF here, take a look at the AF, is what? Is 5x. Oh, let me use white color. It's 5x divided by, what is our CE? Our CE is 5 centimeter. What is our FE? FE is also what? Is also 5x. So this will cancel this will cancel this, and the area of the two will be equals to what? Will be equals to 1. So this was quite a long process to do so. Someone might actually use a different method here to say, but this is the standard one that I want you to know really on proportionality theorem questions. It's very, very important that you know this method. But one can choose a different method to say, okay, what if maybe we just look at these two triangles to say the triangle above is congruent to the triangle below. It means it has the same shape and same size. Can we prove that? Can you see? This side is 5, and on this other triangle, this side is what? Is 5. Sorry about this line. This side is 5. And we have a common side there. Can you see? We have a common side. And this side is 5x, this side is 5x. It means the two triangles are congruent. What does it mean? When the two triangles are congruent, it means they have the same shape and same size. It means their areas will be the same. So you can conclude that if you prove that the two triangles are congruent, then they have the same shape and same size, then you can just say, okay, it means even their areas will be equal. Then you will divide the two areas, the same area, to just basically lead you to what? To getting this one there. So there are many different approaches to that, but I want you to really understand this standard approach and start to conceptualize this content. Okay, great stuff. Thank you very much for joining. Thank you for tuning in. I hope you learned something about solving proportionality theorem questions. Otherwise, that's all for today. Watch up. Coming up next, it's we're just gonna start with finance, and I'll see how it goes on the next session. I saw most of you were saying, please upload a lot of videos consistently. Yes, we will do that, and just keep watch, and don't forget to subscribe if you're new to the channel. Like, comment, let us hear your thoughts and how we can improve going further in this lesson. Otherwise, that's all for me, and goodbye.